The question number 5, part A, asks you what is an unbiased estimator? Estimator is any parameter. Just move on. Estimator is actually any parameter which estimates a particular quality of the population, like average, mean, height, something like that. And for an unbiased estimator, that means unbiased means there is no bias. It would give you the exact value. The expected value of the estimator is exactly the parameter being estimated. On the other hand, a positively biased estimator overestimates the parameter on average, while a negatively biased estimator underestimates the parameter on average. So that's the difference between unbiased biased estimator. So unbiased estimator will give you the exact value of the parameter on average. What the part 2 asks you what is the standard error of an estimator. So the standard error of an estimator is the standard deviation of the prediction of errors, like whatever the errors. So that can be written as, this is the standard error of the estimate, EST. So that is the standard deviation of the errors made. So the error is the actual minus the predicted value. So let's denote this by predicted value, y minus y, the square of this, like just the way we compute the standard deviation, like we take the summation of this and we need to take the square root of this, all the terms, and divide it by the degree of freedom. Degree of freedom for a linear regression is n minus 2, where n is the sample size. So this would be the formula for standard error of the estimate. The rest is simple. Calculate the sample mean and sample variance. So let's calculate the sample mean for these data. Like it is written that repeated 10 times each. So yi bar would be equal to the sum divided by the numbers. So sigma yi upon n. So that would be n. This is 10. So this is equal to 866. Okay. Yeah. Similarly, you can calculate the average for this one. Here also it would be sigma yi, that is 114.65 upon the number of values are sample size is 10. So you would get this one as also equal to 11.465. So this is the mean of the two samples. The formula for variance is given by the variance, or sigma square as we call it, or S square. The standard deviation square is given by sigma. In this case, it would be equal to sigma yi square minus sigma yi whole square upon n. So this you can write it as, this is 1000.31 minus sigma yi 98.66, the square of this upon n is 10. So let's calculate. We get this as equal to 26.93. Similarly, calculating the variance for the other one, you would get that as equal to, this is 1333.31 minus 114.65, the square of this upon 10. This one you would get it as equal to 18.85, that is the variance is 18.85. Now we need to calculate the 90% confidence interval for difference of means. So first of all, you need to write the means of each of them, mu1 and mu2. What are those values? Just write it over here. On the previous page, we can see that the mu1 we got it as 9.866 and 11.465. These are the two means. You also need to write the variances or the standard deviation. So sigma 1 square was 26.93. This is 26.93, and the sigma 2 is 18.85 as far as I remember. Yes, it is. So these are the inputs. So this is the data which we are having. We need to construct a 90% confidence interval for this. So the formula for confidence interval would be this is equal to, actually this is x1 bar and y1 bar. In fact, better write this as y1 bar, and this is equal to y2 bar, because this is the mean of a sample. So you can write this as equal to y1 bar, the mean 1 minus the mean 2, plus or minus, this is the interval, so z score corresponding to 90%. So for 90% confidence interval, the alpha value would be 1 minus 90%, that is 1 minus 0.9, that would be equal to 0.1, and we would take z alpha by 2. So for a confidence interval, we will two-sided confidence interval, we will take alpha by 2, so this would become z.05. So times sigma, the standard error of this y1 minus y2, standard error of the difference of mean. This is a different concept. Okay, so taking this into consideration, this would be 9.866 minus 11.465 plus or minus a z alpha by 2, that would mean z alpha is 0.1, so 0.05 would be equal to 1.6. The standard error sigma x1 minus x2, we are assuming unequal variances, so for that this would be equal to sigma 1 square upon n1 plus sigma 2 square upon n2. Okay, so calculating this is like 26.93 93, the square of this, upon n1 is 10 and n2 is also 10 in fact. 18.85 square on 10 and the square root of this. So you would get the final answer as 10.395. So you could multiply this by 10.395 and hence you would get the range of confidence interval as. Okay, there was small calculation error. So this is 26.93, not square. There is no square on this because sigma 1 square itself is 26.93. So calculating that, we would get this answer, the standard error sigma x1 minus x2 as equal to. In fact, in this case, this is y1 minus y2, like y1 bar standard error of the means. You call this. So y1 minus y2 bar. So this should get it as equal to 2.14, and calculating that, then this is approximately equal to 1.6, 9.866 minus 11.465. So the confidence interval, you are getting it as equal to negative 5.12 to negative 1.92. So that would be your answer. Interpret the interval. So interpret the interval. So interpret. Okay. Interpretation. The interpretation would be we are 90% confident that the population difference. Remember, we are testing for the difference of means. The population difference in the means will lie in the range obtained, like y1 minus y2 would lie in the range obtained. As moreover, as this does not contain 0, like both of them are negative, so this does not contain 0. So that would mean that y1 cannot be equal to y2. So hence we can say that we can conclude that the difference in means of the two samples is statistically significant. That is, y1 is differing from y2. y1 is not equal to y2. First of all, we need to write the hypothesis. Like this is the null hypothesis and this is the alternate hypothesis. It was asked, does the hypothesis that the mean yield using method 2, that is y2 bar, is greater than the mean yield using method 1. So the y2 bar is greater than y1. So this is our alternate hypothesis. So this is also our claim for which we are testing the hypothesis. So here this will contain inequality sign, and the null hypothesis will always contain the equality sign. So this is how we distinguish between them. And this can be written in another form, like we can just shift it y2 over here, and this can be written as y1 bar minus y2 bar is positive, and or y1 bar is minus y2 bar is negative. So this is what is our claim, is that y2 bar is greater than y1. So this is what is our we are testing for. So now after writing the hypothesis, the statement of hypothesis, the next thing which we need to do is find the test statistic. So that is the t value in this case. So that would be equal to like y1 bar minus y2 bar minus the difference. The difference is this, like what is the difference between them? 0 upon the sigma, the standard error, y1 bar minus y2 bar. So Okay, fine. So y1 bar minus y2 bar, we have seen it from this case that is approximately equal to negative 1.6. So let's write negative 1.6 here. Negative 1.6 minus 0 upon sigma y1 minus y2. We calculated it from the previous case. That was equal to 2.14. Okay, this is 2.14, and you will get the test statistics as equal to negative 0.67. And moreover, okay, yeah. So now you need to compare this with the T critical value which we are having. The T critical value, right? The T critical value. It is the value which we can find from this. That is a significant level of 0.05 is given, and the degree of freedom is n minus degree of this is the alpha. This is a one tail test. This is 0.05. The T critical value would be, if you see the T critical chart like this thing, T chart, degree of freedom 9, we are taking n minus 1 because it's a difference of means, and for 0.05 you will get alpha is 0.05, so you will get this as equal to 1.833. okay, and this is a left tail test, so you will take negative 1.833, and now you can compare these two values, the test statistic and the T critical value. So you can actually visualize this like this. 0. So this is the negative 1.833. This is the T critical value. 0.833. What it actually this is negative 1.833 T critical alpha 0.05. It means that this area, the small area, is 0.05, and test statistic T is 0.67. Actually, this is the rejection region. If the T lies less than negative 1.833, then that we would reject the null hypothesis. But here in this case, as you can see, the T value is actually negative 0.67. It is somewhere here. It does not lie. This is 0 in the rejection region. Hence, we can say that as test statistic is greater than T critical value for the left tail test, or this is the left tail test. So hence we can conclude that we do not have actually we do not have sufficient evidence to reject the null hypothesis. So this is what is our conclusion is. Okay. We can say that we do not reject the null hypothesis. Why? Because the statistic is greater than the T critical value. It's lying somewhere here, not in the rejection region. So that would be your conclusion. That was for user significance level of 0.05. What are your conclusions? That is our conclusion, that we cannot say that y2 bar is greater than y1 bar. So here we can say that reject the null hypothesis. What was the null hypothesis? This was the null hypothesis. We cannot reject this and say that this is correct. So I'll interpret that also. This is our conclusion. and our interpretation would be we do not have sufficient evidence to say that the sample 2 y2 bar. Okay, so y2 bar is called as the mean yield using method 2, that that mean yield using method 2 is greater than mean yield using method 1. Okay, we do not have sufficient evidence to say this. This is our conclusion. Interpretation goes like that. So that's your final conclusion and interpretation.